If it wasn't so close to the end of the year, I'd really want to come up with another way to do this. Like maybe I shouldn't assign two different options, or maybe I shouldn't, I don't know. Because this is taking a long time. It's good, but there's got to be a better way to go over homework stuff. Okay, anyway, I'll stick it out for the rest of the year. It's May, I can do it. All right, so find the weight to the nearest 10 kilos of this I-beam. So it's a prism, and the base looks like this. Very common shape for I-beams. What do we call them? I-beams. All right. You could do like rectangle minus these two little rectangles. You could like add up 3 rectangles. I don't know. I think I'm gonna do big rectangle minus 2 of the sort of corner rectangle, like this kind of thing here. I'm gonna take off those. All right, but that might not be really standard. This thing is 30. The height is, the way they have it labeled, it's sort of 20 along here. And 5 above and below, so this is also 30, if you think about that. And this hole then is 20 by, and it says on the top it's 12.5. So the area of this base, I'm just trying to find area. I'm going to take this area minus this area. This is 900. Whoops, I should not be using this color because this is answer mode now. I should be a little bit more consistent. I just wanted to highlight that much. What is wrong with you? Okay. 900, I'll just start answering from there. 900 minus 2 times 20 times 12.5. Come on, calculator, cooperate with me. You're still not cooperating with me. It's 250. How come it's not red? Come on, people. All right, which is 500, so this whole area is 400. The area of the I-shaped sort of stamp on the end of this thing is 400. And then that's in centimeters squared, and then they tell you that the height of the whole thing from here to the back is 10 meters. So I don't know, we could convert this to meters, square meters. We could actually, the whole thing is in meters cubed at the end. We have this unit of kilograms per meter cubed. Let's go ahead and convert this to meters. How many square inches are in a square centimeter? Well, that would be 10,000. We talked about this before. There's 10,000 square centimeters in a square meter. So 400 divided by 10,000 is 0.04. I should be able to do that in my head, but I'm being silly. Okay, it's 0.04 meters squared, and then I gotta take that times height to get the volume. Area base times the height here is 0.04 times 10, which will be 0.4, and kilograms per meter, that's meters cubed. And then I have kilograms per meters cubed. I just take that times that conversion number, which is 7,860, which gives me 7,860, which gives me 3,144. Okay. Kilograms of steel. Okay, so let's find the volume and surface area of this thing. I think I'm going to take large box minus whole. Large minus whole. Volume's not so bad on this. Large is 4x times 5x times 3x. I said that in a different order than I pointed at it, but there you go. It's just, length times width times height, and same thing here. It says x times 2x, and the height of that hole is also 5x. So these are both terms in x cubed. I'm going to have some number of x cubes here, then I'm going to be subtracting from some number of x cubes here. 4 times 3 times 5 is 60. 2 times 5 times 1 is 10. So altogether I have 50 x cubes. All right, surface area is going to be a little trickier, I think. Surface area, I got some more room here. Surface area is, I could do, because basically what's going to happen on the inside here, this exposed surface on the inside here is going to add up. So I think I'm going to just add things together and cross them off as I go. There's 2 of these, correct? There's one on this side, there's one on the other side. So 2 of the 5x by 3x. Plus, I have 2 of these, 2 of the 4x by 5x. It's like I'm ordering, give me 2 of those 5x by 4x. I mean, I should have maybe done lateral area in one step because you're used to that by now. 2 of those. I got 2 of this surface. There's a top and bottom of this. Okay, now this one's a little tricky. It's plus. 2, I should do another line. Plus 2 of the, now that's like rectangle minus rectangle. And that rectangle is 3x by 4x minus the hole on the top, which is x by 2x. And I have 2 of those total. I got a top and bottom, so multiply that all by 2. Plus, I got 2 of this surface, the front and the back, kind of at the hole. That's 2x by 5x. And this is adding to the surface. I know it's part of the hole, but it's creating more surface if you think about it. And then I have the sides of the hole, like this surface here. I got 2 of those, plus 2, and those are x by 5x. Add all that up. I'll do one term at a time here. 2 times 5 times 3 is 30. These are all going to be x squared, I think. 2 times 5 times 4, that's 40. 2 times 12 minus 2 would be 10. And there's 2 of those, so that's 20. 2 of these would be 20. And 2 of these would be 10. Hopefully I did all that right. Looking back, did I do that right? I think I did. So then, oh, they're all multiples of 10x squared, actually. So 30 plus 40 is 70 plus 70, 80, 90, 110, 120. 120x squared. That's what the book got. All right, 29 on page 490. It's actually page 494. We have prisms inside cylinder. Oh, so I just drew them for you there. This is the looking at the tops of all these. They tell you in all of these the radius is 6 and the height of the cylinder is 10. You're supposed to find then of the solids inside there what's the volume and what's the lateral area. Well, volume is always going to be area of the base times the height, and the height is always going to be 10. Lateral area is going to be perimeter times height, and that, of course, the height's always 10 also. So what's interesting about, I'm just making a big chart here then. The thing about the equilateral triangle, if this radius is 6, that would be the distance from here to here. If that's 6, I'm supposed to be able to find the area of this base. All right, if that's 6, this is a little tiny 30, 60, 90 right here, and this part's 6. Whoops, made a little mistake there. Let me go back here a bit. That part's 6. Then what's going to happen then is this. That's the hypotenuse. So this part would be 3, and this part would be 3 square root of 3. So the whole side is 6 square root of 3. Area of the base then is, okay, it's a triangle. Half times 6 square root of 3, and the height of that triangle. This is 6 square root of 3. This is 3 square root of 3. So this whole thing is 3 square root of 3 times square root of 3, which is 9. I could draw that in if you want, times 10. That is going to be a total of, I think, 273 times 9 times 10. Yeah, it's 270 square root of 3. Great. I don't know. Should I do this now? I guess I should. That's 6 square root of 3. So this is the perimeter is 3 of those times the height, which is 180 square root of 3. Great. B, again, radius is 6. So this side here, if this is also 6, this would be 6 square root of 2. The area of the base is 6 square root of 2 squared. This is much easier, actually, than the triangle one. Those triangle ones get nasty. This is going to be triangly 2. All right, so 6 square root of 2 squared times 10. 6 square root of 2 squared is 72, I believe, so this is 720. Perimeter times height would be, perimeter is 24 square root of 2 times 10 would just be 240 square root of 2. The radius of this is 6, which means that every edge of the thing would be 6. The area of the base here is 6 of these triangles, or we could do apothem times, we do apothem times radius, or what was that, half AP? Half times apothem. If that's 6, then the apothem would be 3 square root of 3. Times perimeter, which would be 6 times 6. That's great. Area of a hexagon. Times the height, which is 10. That turns out to be 540 square root of 3. I think. I'm just looking at the book now. I'm actually cheating. 3 times 36 times 10 divided by 2. Yeah, I'm right. And then I'm about to run out of computer battery here. Jeez. All right. Then I got to find perimeter times height. Perimeter was 36 times height, 360. Done. Hardest one by far, I think, is the first one, which you might not have predicted. Okay, this is kind of like one we did not too long ago, where there was a rectangle spinning in space. We have a square. The side is S, or rotating it around a side's like holding it like this and spinning it. That thing's going to flap around and kind of make this kind of shape like this. It's gonna swing out a cylinder kind of thing. This is S. Sorry, not 5. This is S. The radius is S, of course, and it says try to find the Solid form to find its volume. It's a cylinder, first of all. The volume is going to be area of the base times height, which is pi r squared times the height, which is just pi s cubed here. All right, that's it for that page. No, I'm sorry, it's not. It's it for that what the first class actually asked. The next one asked was from the second class, and it was number 24. 24, 2 water pipes the same length have inside diameter. It's just like 22. 2 water pipes of the same length have inside diameters of 6 and 8. These 2 pipes are replaced by a single pipe of the same length, which has the same capacity. So we're talking about same inner volume. 2 water pipes of the same length have inside diameters of 6 and 8. 2 water pipes of the same length. Inside diameter. So I really just care about the size of the space that the water can flow through. They have the same height. One has a diameter of 6. The other one has a diameter of 8. And they have the same sort of length here. This one has a diameter of 8. And they're replaced by one super huge one, same length. Here it's supposed to have some bigger diameter. It's supposed to handle all of this plus all of this. It's supposed to be bigger. So we really don't care about the height. We just care about these areas, really. I need the circle of area 6 plus the circle of area 8 to equal a new circle. So the area of the 6er is pi times 3 squared. The area of the 8er, because that would be the radius, is pi times 4 squared. Starting to look like a Pythagorean triple here, 3, 4, 5. Add those up, I get 16 pi plus 9 pi, I'm going to get 25 pi. That has to be the area of this thing, so R would have to be 5. Or in other words, diameter would have to be 10. There's your sketch for 32. It's not the best thing in the world. It's really hard to draw on this screen because it's so slippery and it's awkward to hold. Anyway, yeah, you got to draw. It might be easier to draw the so I can do it again. You could draw the square prism first. Now, square prism doesn't mean that they're all squares. It just means there's a square on the floor and ceiling. So you got a square there, and then you got to draw this sort of perspectivized circle that kind of hits all 4 corners. And then the edge is going to match the edge of the circle down here, or the edge of the square. This is the outside frame of your box, but I need a similar kind of circle down here. You know, if you dot that or not. And there you go. That might be a little better. I don't know. But anyway, this is, I like this one actually. The question was, find the volume of the prism. Well, the prism is just a box. You need to know this length and this length. Well, this would just, if it's going to fit that circle in there perfectly, this is just the diameter of the circle both ways. Of course, we knew it was supposed to be a square, so this is 12 by 12. So the volume is simply 12 by 12 by 10. Which is 1,440. Okay, we made it. That's the end of the homework for that day. Woohoo!